So yeah, let's get started. So for the second half of today, I will be presenting a bit about water quality, which frankly is one of the events that I like a bit more because I'm more of an earth science person. And while this is not too really earth science, it's a combination of like chemistry and earth science and a lot of different subjects. And you'll find a touch of bio in here as well. So that's very interesting. Um, And as a reminder, we will send all of the recordings after class. Okay, so first breakdown of the event. So this event was here from 2021 to 2022 for the 2020 to 2021 season. And because that season was conducted online, there was a bit of a difference. So in a normal year, marine and estuary ecology would be around 30%. Then we have coral reef macroflora and macrofauna identification, also 30%. And finally, water monitoring / analysis, which is a final 30%. And the salinometer, which was dropped in the seasons I competed it in, would have normally been 10%. And I know every one of you loves a Kahoot. Yes, there will be a Kahoot. It's right here. Don't focus too much on it for now. Okay, now let's get started with a bit of the content. So water can have a few properties. So let's just dive into them right now. And actually some of the points that I have made in my dynamic planet presentation last Friday will come back here. So those topics will resurface, like salinity, for example. Salinity basically is the amount of salts dissolved in water. Now, I think I should clarify a point that I have made that I maybe didn't make on Friday. Salts in this case refers to ionic compounds. So for those of you who are familiar in chemistry, ionic compounds are basically when there's a metal and a non-metal bonding. So sodium chloride, which is like the table salt that everyone knows, is considered to be a salt. But there are also, please don't draw. But there are also other salts, including salts of like calcium or something. Yeah, okay, drawings off the board now. So usually, sorry, usually animals can only be able to tolerate so much salinity, like because if you have too much salt, then maybe the salt will actually pull water outside of your body because water kind of wants to go from from high pressure to, that's not how to describe it. Water kind of wants to even itself out, right? And if there are less salts in your body than there are outside, then your water kind of wants to equally distribute the salinity. So water will move outside your body and you will basically dehydrate in too much salt water. So definitely way too much salt is not good. But then again, you also want some salts to be able just to have like the essential amount. You can also die from having no salt. Yes, don't like dunk yourself in the ionized water either. That's not ideal. Next. Okay. Next topic I'll talk about is pH. So, is it possible to drink too much water? Yes. In fact, more people die of overhydration than underhydration, if you can believe that. But okay. Anyways, getting back on track. How many of you know of the concept of pH? One yes. Um, a few raised hands, a lot of yeses now. Okay, so for those of you who don't understand pH, I'll explain it like this. So pH basically measures the concentration of H plus ions dissolved in water. So H plus is just, they're just hydrogens. And and now there's one first concept that is pretty important. If you have a lower pH, then you are more acidic. And if you have a higher pH, you're more basic. And the pH scale runs from about 0 to 14. So like 0 is you're completely full of H plus ions. And no, pH does not stand for penguin hamburgers. It stands for, I think, P is something, but H is definitely hydrogen. So it measures the amount of hydrogen in water. And basic is pretty much no H plus. So that's really basic. Power hydrogen, yes. Okay, thank you. Thank you. Imagine not knowing what pH stands for. Couldn't be me. So anyways, there's another important concept to know is that pH is a logarithmic scale. And basically what this means is that from a pH 5 to pH 6, something with pH 5 has 10 times more the amount of hydrogens in it than pH 6. I'm explaining pH right now. pH defined as H12, potential hydrogen, power hydrogen. I'm not quite sure what exactly is what it stands for. I have students telling me it's power hydrogen, some students telling me it's potential of hydrogen. I'm not quite sure. And yes, water is neutral at pH of 7. So pH of 7, you have balanced parts of H plus and maybe OH minus, which we won't go into too much detail. But basically, pH just measures how acidic some water is. So obviously, you don't want to live in way too acidic water. You don't want to live in way too basic water either. So definitely. So yeah. Let's see. Next topic is water hardness. So water hardness is actually pretty similar to salinity. It just checks for the amount of dissolved ions in water, but specifically with Ca and Mg. Who knows what Ca and Mg stand for? Okay, Ca is very obviously calcium. Oh, if you have to go, yeah, feel free to hop off. And Ca is not California. Well, Ca is sometimes California, but not now. Mg is magnesium. So these two, so basically we just test water hardness with calcium and magnesium, these two ions. So if you have way too much, if your water hardness is way too high and you have a disproportionately high amount of these ions, definitely not good water. And then finally, on this side, we'll also talk about temperature, which everyone should know. Temperature is actually inversely correlated with DO, which is dissolved oxygen. We will get into this, I think, in a few slides. And by inversely proportional, we mean that if we have a high temperature, that means we have low DO. So generally, this would mean that like if you have a higher temperature, then your water is worse. And you guys have all heard that cold water is usually more like clean than hot water. Do any of you know of this fact? Or have heard of it before? I have a few yeses. What about boiled water? Please don't live in boiled water. That would be really, really bad. But yeah, this is primarily the reason, and the reason why DO is low before is, well, bacteria, yeah, if you have not high enough temperature, then you have a lot of room for bacteria to grow, and that will lower the DO. DO means dissolved oxygen. Did I miss a slide? I didn't miss a slide. All right, but DO means dissolved oxygen. Basically how much oxygen there is. Like you have oxygen in the air, right? But actually you also have oxygen that's dissolved within water. So like fish and stuff, fish and the water organisms, they will need to rely on the water that is dissolved inside water to be able to breathe. More germs equals more methane. I have not heard of that. And I'm not, it kind of makes sense. What is the pH of drinkable water? That is a very good question. The pH of drinkable water should be around 7. I think if you're going, yes, 7 probably is the best. If you want to go like maybe a bit further, probably can go like for 6.5 or something. I think you can go a bit further with on the basic side, but don't stray too far from 7 is probably, yeah. 6.5 and 8.5. That is a really familiar number because I will talk about it really soon. So yeah, let's move into pollution. So yes, that is true. Acids and bases do cancel each other out. I'll talk about radionuclides in a second. What does 1 pH water taste like? Don't try. Okay, moving on to pollution. So the EPA has 6 classes of pollution. There's microorganisms, disinfectants, you have byproducts of whatever stuff you're making like in an industrial scale, organic compounds, you have inorganic compounds, and radionuclides, which I had a question about. Radionuclides are just radioactive nuclei, radioactive elements. Can the acid melt you? Common misconception, I don't think it melts you, but what it happens if is that it like it dissolves you kind of. It can burn you, but more commonly it can dissolve some compounds within you. Corrosive, yes. Oh, okay. I have a misconception about pH I want to talk about. Vinegar is high, cabbage juice is 7, and baking soda is low for pH. Actually, it's the opposite because basic compounds have a higher pH, remember? So we would actually have vinegar be slightly lower, maybe like from a 5 to 6 is my guess. Cabbage juice is 7. I don't know about that. Baking soda probably higher, like 8 or 9. Yeah. Dissolve and melt are basically the same thing. Not really. Dissolve, well, melting is like when you have turn from solid turn into liquid, but like dissolving is if you have a compound and then it kind of breaks apart another compound. Also don't try 14 pH water. EPA does not stand for energetic pooping acrobats. It stands for the Environmental Protection Agency.
What would isn't this also in Green Generation?
Maybe this is also in Green Generation. I'm not too familiar with that event, but yeah. Is there -1 pH? I don't think so.
Well,
Okay,
what 14 pH water tastes like?
1 pH,
14.
14. Don't try 1 or 14. That's a bad idea.
What would it taste like?
I don't know. I don't think anyone knows, or nobody has tried it out before.
Wait, a negative pH can occur.
Can it?
Well, it says that it can occur when the molarity of hydrogen ions in a strong acid is greater than 1N.
Okay. Maybe, but like that should be pretty rare. Yeah. Well, okay. Normal water is pH of 7, but there's always some dissolved compounds in there that will change it. I think pH can only be applied to water compounds. Would the pH affect the taste? Yes, very good question. So actually, acidic compounds taste sour, like vinegar or like tomatoes. They taste sour, they're bitter, they're acidic, but bitter stuff tastes basic. No, stuff that tastes bitter is basic. Yeah. Tomatoes are not sour. I disagree. Lemon juice, yeah. Tomatoes are kind of sour. Come on, give it to me. pH of hand sanitizer is probably higher. Okay, we're getting on a massive tangent on pH. I will go on with my presentation now. Smile. Okay, so there are 2 main types of pollution. You have point source and non-point source. So point source pollution come from a clearly defined location. Like if a pipe in your sink broke and then suddenly there was an excess pollutant coming in, that would be a point source because you definitely know where it's coming from. If you fix it, then it's fine and you will not have more pollution. But non-point source can come from a variety of locations. Like if you have large scale agricultural runoff, like if you use a lot of fertilizer and then there's a lot of rain and then the rain washes the fertilizer into the ocean, suddenly there's a lot of area which could have a lot of fertilizers. So there isn't like one specific place, rather it's like a general area. You're guessing that non-point source is worse, that is correct because it's harder to address with. I did this in CU stuff science, very cool. All right. Yeah, okay. Now I'll go into dissolved oxygen in a bit more detail. So if there's one indicator of water quality, it is dissolved oxygen. You can't have, I don't think there is a better indicator of water quality. Dissolved oxygen, if there's a high dissolved oxygen, you can probably live. If there's low dissolved oxygen, goodbye. And the chart on the bottom right shows like what are considered acceptable levels of DO, what are bad levels of DO. And dissolved oxygen is not drinkable. Like it's kind of like dissolved oxygen is a concept. Think of it as think of it as like the amount of oxygen that's inside water. That's basically what it is. Is it air? It's not gaseous, but well, yeah, it's not really gaseous. What pollution does boiling help with? I'll get into that later. You can use bugs to see how clean water is. Oh, yes, that is a good point. That seems a bit advanced, though. How do you measure the amount? Okay, I'll answer that right now because it's on the slide. So the one dissolved oxygen test you should right now know is the Winkler method, which uses something called titration. Basically, you have like a sample and then you add like an amount of acid or base that, and then you can be able to tell how acidic or basic the initial compound was. So it's useful for determining chemical properties of a solution. So yeah, Winkler method equals dissolved oxygen test. Why is it measured by fish? Because that means that's about how much fish that could live there. Is that where all the bubbles come from when you boil water? No, that is a different thing. Is 10 like overpopulation? Well, consider dissolved oxygen as the amount of oxygen we have on air. Like if we have 18% oxygen in the air, like which we have about now, and we're doing fine, then like 20%, 25% shouldn't be a problem either. It's not going to like suddenly make us be better at breathing and better at reproducing. So it's not quite overpopulation, but it just means like less risk of dying out. What does acid taste like? Sour. When is Kahoot? In a bit. We're gonna go really over time with the amount of questions I'm getting. How much fish could exist with DO4? I don't know the exact number. Focus people. Okay, I love that you all have questions, but let's get through the material first. Because at this rate, I'm going to have to do quite a bit of speeding up. Okay. Next concept is biochemical oxygen demand. Basically, this is how much the organisms like need oxygen. BSP like okay, I got you. So this is basically the rate which dissolved oxygen is used up. On the bottom right, I have a formula, and in like kind of opposite to dissolved oxygen, but biochemical oxygen demand is inversely proportional to water quality. So if you have a high demand, that means, you've messed up somewhere. Is organic matter bad? Yeah, it's a pollutant. So basically why this is the case is because in water, all of a sudden, if you have a lot of things dying, then you're going to need to raise the biochemical oxygen demand because you need decomposers to decompose all of the dead material. I'll move into this a bit more in the eutrophication slide. So yeah. If you boil water and let it cool, does that more deal or stay the same? Say is the same. Turbidity, yes. Turbidity is another indicator of water quality. Basically, it measures how clear the water is. So this is probably like the most intuitive measure of water quality. If you have very murky water, don't drink it, please. Turbidity is mostly caused by erosion. Is that P? I don't think that's P. It's caused by erosion. It's determined by the amount of light that's allowed into water. So besides just drinking all of sediments, it's really bad to have high turbidity because that means like you'll have not a lot of not a lot of light going into the water, so you can't photosynthesize, and then dissolved oxygen goes down, and as we know, that is not a good sign of water quality. So now I'll explain the Secchi disk that is shown on the bottom left. This is used to measure water quality, specifically turbidity. So basically how you operate this device is you lower it into water, and then once you lower it to the point where you cannot see it. And this disk has very high contrast. So like the black and white are very easy to be told apart. So then this, given the amount of distance the disk is from the surface, you can calculate how dire turbidity of how dire of a problem turbidity is. I mean, soup has high turbidity. Sure, you can think of it that way, but trust soup. Okay, fecal coliform is a very fancy way of saying poop bacteria. Basically, it comes from poop. If you have a lot of fecal coliform, that means there probably happens to be a disease somewhere and your ecosystem is in a bit of a trouble. So like some diseases can be like bacteria like hepatitis and typhoid, but you could also have other like viruses or something that are in the water. I have a lot of people getting hyped up about poop. Please don't get hyped up about poop. I guess you can, but not really. What about pee? Fun fact, pee has no bacteria in it. It's disgusting, but pee doesn't have bacteria in it. I am discussing many people, so I will refrain from elaborating.
Fun fact, fun fact, the ocean is full of pee.
Yes. Okay. How you test for fecal coliform is you can test by filtering water and incubating water. Basically, like incubation is if you have a sample of water and then you know there's some bacteria, then you can heat up the dish and then you'll let the bacteria colony grow. And like on the bottom right, you see a lot of bacteria, and this is a big uh-oh. If you are getting this, I will speed through this. So boiling helps reduce fecal coliform. I had a question on that earlier by basically preventing the ability of bacteria to like reproduce. So I think heat is able to kill the bacteria and cold is able to stifle bacterial reproduction. Moving on
What
into
would
like
ice do to the fecal coliform thing?
ice. Theoretically, if you froze water, I guess you'd remove fecal coliform. Leon, do you have a question?
So is it possible to like if you stuck fecal coliform more like bacteria on some very cold place, like like a distant moon, an icy moon or something, or it just immediately eradicate the bacteria because it's so cold, or would the bacteria start blooming?
I think the bacteria would die. Let's digress from the topic since we have quite a few members of grossed out audience. Okay, let's move on to a slightly less disgusting topic, eutrophication. And you know how sometimes you see these like stagnant ponds with all this green stuff, all the green stuff on the surface? Yeah, that is dead algae. So doesn't cold preserve bacteria? I have no clue. We have to go on though. So basically what happens is if you have a lot of nitrogen and phosphorus, which mostly comes from fertilizers in farms, by the way, and no, that is algae, it is not Shrek's oogers. What the heck? So basically you have nitrogen and phosphorus into the water, right? But once you have a lot of nutrients in water, then algae will come and kind of use up all the nutrients. And then they'll all die because there aren't more nutrients left. But when they die, then now there's a massive dead algae and they need to be decomposed. So the decomposers will need to come over and use up a lot of oxygen. So this is where I return to biochemical oxygen demand. So if you have a high biochemical oxygen demand, it means you have a lot of stuff that needs decomposing. But that means you'll also steal from the oxygen from other organisms. And if it gets serious enough, then there might be completely zero oxygen in a body of water. In that case, we'll call it a hypoxic zone, basically zero oxygen. And that is a very bad sign for water quality. Yeah. Eutrophication is basically this process of the algae dying. Long story short, algae come, algae die, everything die. Not bad. Dead zone, yes. Dead zones, hypoxic zones are pretty similar. I just pretty much went over all of this stuff. What happens when you drink zero oxygen water? You don't drink water for the oxygen in the first place, so I'm not sure it matters too much. You also have these things called facultative ponds. Basically, you have a pond of wastewater with algae, and algae will produce oxygen. And so if you're wondering why we can't use the oxygen the algae produced for the decomposition, then this is because the oxygen that the algae has produced goes into the atmosphere, which isn't the water. So it's not DO. So this doesn't, the oxygen here does not account for DO. The temperature and DO are mostly correlated. Doesn't mean the hypoxic zone is really hot. Not necessarily. I guess you should take temperature and DO are mostly correlated with a bit of a grain of salt. Like, it's not always true, but usually if you have like two identical bottles of water, save their temperature, and then you heat one up, probably the DO is less. Why is ozone deadly if it's just O2? Ozone is not O2, ozone is O3, which is weird to think about. And basically these facultative ponds will have will treat wastewater with algae. So algae, both good and bad, depending on how they work. Really complex organisms. Next, I will move on to wastewater treatment. And I'm sorry if this is a bit lower quality. And so if you have a cheat sheet, you should definitely just chuck an image here on it and then like deal with it later, because there are a lot of steps. So it's not the most, it's not the most like beneficial to memorize everything. But basically the primary treatment is you let some of the heavier stuff drop. The secondary treatment is you do a bit more stuff to get the heavier stuff to drop. And then finally, in the third stage, you like chemically treat it. So you remove it of other impurities. So stuff like turbidity is cured, like turbidity and fecal coliform are addressed in the first second. But I think others like other things like maybe hardness or some other stuff is, yeah. Ahem the time. I had too many questions. I'm speeding through stuff right now. Here are a few biological concepts that are important to water quality and basically have to do with stuff around the ecosystem. So this, on the right, does anyone know what this is called?
Food web.
Food chain.
Food web.
Ecosystem.
I have a lot of
Food
correct
web.
answers.
Web.
Food web is
Okay.
correct. Andrew Liang is not. This is not me on the right. But basically, if you've studied food webs before, then you'll know some of these terms. Like you have primary producers, primary consumers, secondary consumers. You have apex predators. I'd also like to introduce something known as a keystone species. So keystone species are really important for the environment because let's take this small planktivorous fish for an example, right? If suddenly this small planktivorous fish was removed, that means you have like a lot more zooplankton, and then that would mean that like the population would be disproportionately tilted towards zooplankton. And at the same time, these three animals suddenly find themselves with little food. And then if these three animals find themselves with little food, this osprey finds itself with little food, bald eagles find themselves with less food. So basically the removal of one species can cause like a large effect to spread across the whole web. And that is why these are a keystone species, why they're really necessary for the environment. Yeah, basically if one species die, everyone have less food is basically how I would describe it. Is grass keystone not in the context of what aquatic environments? Maybe for some other ecosystems, probably not. And one more concept is biomagnification, is basically when toxins accumulate up the food web. So like if all of a sudden all of your zooplankton are like poison, then small planktivorous fish will eat these zooplankton. These guys will be poisoned. these bivalves will also get poisoned. And then everyone here actually would get poisoned. And then everyone here will get poisoned. So that clearly is a bad thing. The thing with biomagnification is that as you move up, the animals towards the top get more poisoned. So that is something to watch out for. Herbivore ducks. Zooplankton are animals, not plants. One more thing, coral bleaching, which one, you will find in Dynamic Planet. Two is a really cool concept. There are two main causes for coral bleaching right now. The first is ocean acidification, which is basically a decrease in the pH across the Earth's oceans. This is kind of a pH reminder again. pH decrease is more acidic, so more acidic. Biomagnification is what happened to our bald eagles with DDT. And if you're paying attention right now, I'll tell you this is a Kahoot question. So yeah. Rising temperatures are also a cause of ocean acidification because they speed up basically this process. So remember when I said pH is measured by the amount of H+ ions there are in water? Well, look who we have here. It's our best friend, H+, and that makes things more acidic. So yeah, that is how ocean acidification works. Can't you guys dump a bunch of basic chemicals, I guess? Good luck finding enough of that because oceans are massive. Like, they're massive. So you probably don't have the amount needed. Just a little at a time. Yeah, how long are we gonna wait? One Kahoot. I'm speeding through. Everyone trust me. I'm going really quickly. Nutrient cycles, I will not spend a lot of time on. Yeah, so if like the nitrogen cycle and carbon cycle, basically all these do are how basically what these represent is how nutrients spread from one place to another within the ecosystem. And so like if you have one process that is going really fast, then suddenly you might disrupt the cycle. So yeah, there are no questions in the Kahoot on nutrient cycles, thankfully. Here are more nutrient cycles. You have phosphorus and most importantly, water. Most importantly, water. Most importantly, water. Water is really important. You should know the water cycle. Preferably keep an image of the water cycle in your cheat sheet, even if you know a lot of it. Estuaries. Let's move into estuaries right now. Who knows what an estuary is? Can someone define an estuary is a better question. It's not a water thing. Well, be more specific. It's not really an offshoot of a river either. So it's not watershed either. Estuary basically are where rivers meet the ocean. It's not where your mom goes to buy stuff. So if you look, you can look at estuaries from two different ways. And in each way, there are 4 types. First is defining them tectonically. So the first one is a drowned river mouth. So basically, this would kind of be something like if you had a river once and then the ocean levels rose and then it pushed the river further back. So that would be a drowned river mouth. A fjord is the thingy in Norway, which you see a lot. It's like these really deep U-shaped lakes. And these are carved out by glaciers. You also have bar built, which is like if you have rivers and then there are like some barrier pieces of sand that are separating it from the ocean, that would be bar built. And tectonic, which if you live in the Bay Area, the San Francisco Bay is an example of a tectonic estuary. Do you guys know? Basically, it's when you have plates that kind of separate up and then they form a place where water can go. And the other way to look at estuaries are from how well the waters are mixed. So if there are things like poorly mixed estuaries where salt water kind of drives a wedge into the fresh water, you have partially well mixed, and then you have partially well mixed in the bottom here. This is really well mixed because salt to fresh water is a very smooth transition, and fjord shows up again. So yeah, denser salt water is on the bottom. Macroflora and fauna, basically what you have to do is just chuck a lot of images of macroflora and macrofauna onto your cheat sheet. There really is nothing else you can do. You just have to have a lot of information on your cheat sheet. Honestly, most of your cheat sheet will be for flora and fauna, or at least that's how I did it in my time. A salinometer video, which I will skip due to popular demand. Tips and tricks. Yeah. So and often you'll be analyzed reading real world problems, and there are a lot more pollutants that I've mentioned today. So go ahead and take a look at them. Well, this part needs no introduction. I'm not sussy. Trust. I can turn it on. It is on actually. Everyone's names are so positive. 20 more seconds for joining. Where is the start button, by the way? It's here. No, I think everyone who wants to join us here. Let's go. Start. Question 1. I did not mention this. Okay. The correct answer for this one is nitrates. I did not mention it. But basically what happens here is if you have nitrates, too much nitrates, and you actually have something called blue baby syndrome. It's when your babies get blue, like literally blue. It's really funny. I love it. Let's skip the question. Rick asked this first. Does it harm the baby? Yeah, I think it does, you know. Okay, the Winkler method uses which method? Did I not save this? Uh-oh, okay. Nevertheless, I still talked about this. So good job to the 27 people. It is using titration to measure DO, dissolved oxygen. Actually, I actually thought a lot of people would choose the other kind of wrong answer. Which of these is a major cause of ocean acidification? I mentioned this a bit back. Okay, I said that ocean acidification was caused by carbon emissions and rising sea temperatures. Yes, I did. I totally remember saying that. If you didn't listen, that's a you problem. Next question. Okay. Without sea otters, urchins will eat all the kelp in a region and remove the species. Sea otters are most likely which of the following? Think of sea otters as a species that keeps other species kind of in check, because like if they're removed, all of a sudden you have widespread effects spreading throughout the food web. And that would mean sea otters are keystone species. They are not the apex. Well, they are the apex predator. That's true. I mentioned this. Okay. I didn't mention this as an excuse. Okay. I mentioned it. Trust. Technically, they are the apex predator, but you don't have enough information to say that yet. And actually, killer
Answer
whales can
now?
sometimes eat sea otters. So, fun side note. Which of the following is an example of non-point source pollution? This one requires you to think a bit. This should probably say a broken pipe in a factory. Okay. A lot of people also chose wastewater dumped into a river by a nuclear power plant. Well, in this case, you know which nuclear power plant is. I said a power plant, so then you'll be able to point it down. So that would mean it's a point source. But runoff from a street after a storm, if you have a whole city, you have a bunch of streets, like car oil that gets dripped on the ground, that gets washed into the bay. Who knows which street it came from? That's why it's a non-point source. Next question. I told you this was a question during my lecture, so you guys should probably get this. No pressure though, trust. Okay, I did mention it was biomagnification. Bioaccumulation is kind of similar, but not really. This is biomagnification because it's from bottom up. For the misclickers, well, it happens sometimes. The Chesapeake Bay was formed when sea wolves rose to flood the mouth of the Potomac River. What type of estuary is this? I will say this right now. The coastal plain was the first type of estuary we looked at, where that was the first type of estuary based on tectonics. So with that, I've pretty much given the answer away. Yes, it's a coastal plain estuary. It's not a tectonic estuary because I didn't mention anything about plate boundaries. And in actuality, there are no plate boundaries on the east coast of the US. So it is a coastal plain. It's not carved by glaciers, as Ford would suggest, and it doesn't match the definition of bar-built. Movement of water on the surface underground is okay. This is this is like water cycle knowledge tests. There should be you can probably process of elimination this one. Is life fair? No, life isn't fair. Okay, so I'll tell you why it isn't runoff. Runoff is surface towards the ocean. So infiltration is when water goes from the surface underground. Runoff is when water kind of just goes out into the ocean. So I'm a noob, I disagree. Maybe at question setting, okay, I'll concede. But infiltration is a movement of water underground. Runoff is on the surface. Runoff doesn't happen underground. So that's a good thing to keep in mind. Gavin is popping off. Hold up. I'm sorry. I meant to remove this question and I didn't get the time to. So somehow it didn't save. Here's my questions. My bad. Water treated by chlorine. Which could this be? Well, here's a hint. Pools are treated by chlorine. What do pools test? What could be in pools that is bad? Actually, most of you got this. That is good. It is correct. Fecal coliform. Yes, you're afraid if you're swimming in bacterial water, get the heck out of there. Don't swim in a contaminated pool. That's not a good idea. Okay, this is our podium of kind of scuffed Kahoot, I will admit. So yeah. Baby P could be in pools. That is true. And a very close 10-point game. Julia Fractal gets first. Good job, everyone. I guess that ends things off for today. Thank you for coming. Goodbye, everyone.
Thank you.
Thank you. Bye.
Thank
Thank
you.
you.
Bye.
Bye. Thank you.
Thank you. Bye.